All right, so today we are on the back side of our 6.6 notes, and we are dealing with something now called composition of functions. Okay, first we've done function operations, which are just our adding, subtracting, multiplying, and dividing functions. Okay, that's what we did yesterday. Today we're doing compositions of functions. And what compositions of functions mean is that we are taking a function and plugging another function into it. Okay, so where does that come from? Well, first off, let's talk about function notation. So back from section 2.1, we said if we have a function f of x equals 3x plus 2, let's say. Okay, so if I've got that function, and of course that's written in function notation, we said that we would be able to plug in a number such as, say, 2. In every place we saw an x, we would put 2. And then we evaluate. Well, 3 times 2 is 6, plus 2 is 8. So f of 2 equals 8. All right? And we said the nice thing about function notation is that it not only told us the result, the output, but it also reminded us what the input was. Okay? In order to get 8, we plugged in 2. Right? Okay, so that was function notation. Well, what we're doing today is rather than plugging in a number, we're going to plug in a function. Okay? We're going to plug in a function. So for example, f of x equals 3x plus 2. All right, well, what if I have f of g of x? Well, then that's going to equal 3 times g of x plus 2. And then we have to know, well, what the heck is g of x? Well, let's say, for example, that g of x was 3x. Well, then that means that we are going to come in here and say, all right, well, that's going to be 3 times 3x plus 2. We are literally taking that g of x function and plugging it into our f of x function. Okay? So that's called the composition of functions. We're taking one function and plugging it into a second function. Any questions on that? What it means? Not yet, okay. Then let's take a look here at the notation of that. I warned you guys yesterday that we have some funky notation, okay. Today we use that little circle. This is a key piece right there. Today we use that little circle to indicate composition of functions. Okay, so this says, and the way we read this is g of f of x. Okay, g of f of x. That's g and then that little circle, f of x. So, we're taking one function, plugging it into the second function. One thing you need to remember when doing this is that f of g of x is not always equal to g of f of x. If you change the order in which you're doing these functions, it could change your outcome. So watch out for that. Make sure you're plugging in the proper one. So, let's take a look at our first example. Before we get into anything else, let's take a look at this example. They are asking us to evaluate g of f of negative 3. Okay? Well, before we do that, I want to evaluate g of f of x. Okay? G of f of x. Now, how do I translate that? Well, that means I take my g of x function and I plug into it my f of x function. Okay? How do you remember which one goes on the inside? Well, when you look at the first notation, you could just simply put in one set of parentheses there, and it shows you which one's on the outside, which one's on the inside. Okay? Get what I'm saying? All right. So, I want to take my g of x function. which is x squared. And every place I see an x, I just want to put parentheses. So that means I have x squared. There's my g of x function. Well, then I want to plug into that the f of x function, which is x minus 5. Okay? I literally took the f of x function here and plugged it into the g of x function. Well, now I want to simplify that down. So that means I have to take x minus 5 times x minus 5. So I FOIL. X squared minus 5x minus 5x plus 25. So I end up getting x squared minus 10x plus 25. That is g of f of x. Any questions on just getting that far? Okay, so that's the first part. That's finding g of f of x. Well, they didn't actually ask us to find g of f of x. They want us to find g of f of negative 3. So what does that mean? That means we plug negative 3 into our g of f function. Okay? So I am then going to take g of f and plug negative 3 into it. Every place I see an x, just give yourself open parentheses. All right, so there's my g of f function, and I'm plugging into that negative 3. So, negative 3 squared gives me 9. Negative 10 times negative 3 gives me positive 30. And then plus 25. So I end up getting 64. So therefore, g of f of negative 3 equals 64. Well, if you look at the next set of questions, they're telling us that f of x is 3x plus 2. They're telling us g of x is 2x squared, and that h of x is negative 4 over x plus 3. They want us to state the domain. Well, let's go back up to our rule up here and talk about domain for a moment. It says up here that the domain of f of g consists of the x values in the domain of f. So saying the x values is really kind of redundant. Okay, they're just because the domain is the x values. So the domain of f of or g of f consists of the domain of f for which f of x is in the domain of g. What the heck does that mean? Let's draw a picture. You guys remember when I first introduced functions to you, I kind of drew a little diagram and called it a function machine, and you had the input in the top and it spit out a number on the side. Remember doing that? Sort of. Well, you'll see it again right now. A function machine called f of x, if I input a domain, which we know are our x values, that function will add, subtract, multiply, and divide that thing, and then output a y value or a range, right? Input, output. Well, what they're telling us is that if we're dealing with g of f of x, that literally means we take our g of x function and we plug in the f of x function. And so if we're evaluating these, you have to evaluate f of x first. Okay? Then, whatever you get for that, you're plugging it into the g of x function and evaluating that one second. Right? So if I did a diagram of this, I would have some input number, x, or domain. I would dump it into my f of x function, which would then output a y value or its range. Those outputs are then dumped into the g of x function, which then, of course, means they are the domain for that g of x function. And that would then spit out our final output or range. Okay? So this is where the rub happens. That's where the rub happens. We need to be able to see, to be able to visualize, okay, if I'm plugging numbers into that first function, what type of numbers are going to be coming out of it? Because then we need to analyze, do those numbers coming out conflict with the domain of the second function? Do the numbers coming out of the f of x function conflict with the numbers that are supposed to be going in to the second g function? Okay, so let's see what that looks like. Let's see what's happening in our next set of problems. So let's do the f of g one first, that second one first. So looking here, that is another way of writing f of g of x. Okay, it means the same way, or same thing, slightly different notation. Okay, so we're dealing with the f function and the g function. Let's take a look at the f function and g function for a moment. Looking at just the f function, what is its domain?
Negative infinity to infinity.
All real numbers, absolutely. Negative infinity to infinity. It's a line. I can pick any x value I want, and I can evaluate that function. Okay? Let's look at the g of x function. First off, what shape is it?
Parabola.
Parabola. It's an x squared. So what's its domain? Absolutely. All real numbers. Okay? So our f of x function is 3x plus 2. Our g of x function is 2x squared. We want to evaluate f of g of x. So that means start with the f of x function, 3x plus 2. 3 times x plus 2. That was it, right? I forget. Yes, 3x plus 2. All right. So we started with our f of x function. Now I want to plug into that the g of x function, which is 2x squared. I want to simplify. 3 times 2x squared gives me what?
6x squared.
So I have 6x squared plus 2. That's as simplified as it can get, so that is my f of g of x function. All right, so now we want to talk about its domain. We said that the domain of our f of x function is all real numbers. The domain of our g of x function is all real numbers. So which one gets evaluated first, the g or the f?
F.
The inside one gets evaluated first. So when we're plugging numbers in, you're looking at the domain of g, all real numbers, right? Well, if I take a number here and I plug into it, so let's say, again, we want big ideas. So think positive, think 0, think negative, okay? If I plug in a positive number in for x squared times 2, what do I get coming out?
Positive number.
A positive number. I take a positive number, I square it, and then I multiply by 2, so I get a positive number, right? Okay. What if I plug in 0?
Positive number.
I get 0, right? I get 0. 0 squared is 0 times 2 is 0. What if I plug in a negative number? I get a positive number, because I take a negative number squared, I get positive, and then times 2 is still positive. So really, the range, the output of this equation is going to be from 0 to infinity, right? It's all 0 and then all positive numbers. That's my output. Does that output conflict with the domain of our f of x function, 3x plus 2? Is there a problem? Are there any of those numbers that we can't use in that domain? Well, we could use them. Are we going to get them? No. They're never going to show up, but it's not like we can't use them.
Okay.
You see what I'm saying?
Yeah.
They're just not going to show up. Okay? So there is no conflicting numbers. Everything is okay. We can use it all. So our domain for our resultant function is negative infinity to infinity. Okay? We can plug anything in for x we want. All right? 6x squared plus 2. That resultant function, I can plug anything I want in for x because it has no conflicts. I evaluate g of x first. I'm going to get 0 or a positive number. Plug that into f of x, and I'm going to get my value. Okay, I can pick any number for x I want to do that. Okay? Making sense?
I don't understand how the domain didn't change.
How the domain didn't change. Okay, it's a great question. First off, remember that the domain of f of x...
Teachers, please excuse this interruption. All students in the green Let's Talk shirts, please meet in the front office at this time.
All the domain for f of x was all real numbers. The domain for g of x individually was all real numbers, right? Okay, so again, think back to those function machines. If I take any real number and I plug it into my f of x function, oops, I'm sorry, we've got to plug it into our g of x function because that's the one that gets evaluated first here. I know it's getting evaluated first because it's on the inside, okay? So I plug it into g of x. My output is going to be from 0 to infinity. It's my range. How do I know? Because I look at the equation. What if I plug in a positive number? What am I going to get out? Positive number. What if I plug in 0? What am I going to get out? 0. What if I plug in a negative number? What am I going to get out? A positive number. So regardless what I put in, I'm going to get out 0 to infinity. Okay? That then becomes the input for our f of x function. Okay? That then becomes the input for our f of x function. Well, the f of x function had a domain of all real numbers. So is there any problem plugging 0 to infinity into it? No, because it doesn't conflict with its domain. I can plug 0 to infinity into a function whose domain is all real numbers, right? Yes?
Yeah.
Yes. And so therefore, there's no conflict. And so the domain of our result function, if you look up to the rule at the top of the page, it says that the domain of your result function is going to be all the numbers in the, or all the items in the domain of the first function that don't conflict with the second function. Okay? That's what we're talking about here. All the domain for our f of g function is going to be all the numbers in the domain of g that don't conflict with the domain of f. Okay? Let's take a look at the first one in this set, h of g of x. Now again, h of g of x means h of g of x. It spells hog. All right, hog. H of g of x. Which of those functions is getting evaluated first? The g of x function, the inside function, gets evaluated first. Okay, so we need to look at the domain of our g of x function, which is negative infinity to infinity. All right, we're happy with that. But we then need to look at the domain of our h of x function. We haven't done that one yet. We're looking at the h of x function. What's going to be that domain?
Negative infinity to negative 3.
Parenthesis united with negative 3 to infinity. Yeah, that means all real numbers except negative 3. That's what that means. We're excluding negative 3. Why? Because negative 3 makes that denominator equal 0. Right? Okay. So, we know that. All right. Looking back at what we have, looking back at what we have, I'm going to draw my quick diagram. I have my input going into the g of x function. I'll have an output of that then going into the h of x function. Okay? I have all real numbers going in, because that's the domain of my g of x function. Okay? So let's see what happens here. H of x was -4 divided by x plus 3. So I have -4 divided by x plus 3. Okay, and I'm plugging into it the g of x function, which is 2x squared. Well, if I go to simplify that down, I get 2x squared plus 3 on the bottom. So that is my h of g of x function. Okay? Well, now we've got to decide about its domain. So, looking back at that little chart I drew at the top, if I take all real numbers and plug them into the g of x function, which is 2x squared, what kind of numbers do I get coming out of that?
Positive and 0.
0 or positive numbers? Because if I plug in a positive number for x, I'm going to get a positive number coming out. If I plug in 0 for x, I get 0 coming out. If I plug in a negative number for x, I get a positive number coming out. Right? Because I have to square it first. Okay? Grunt once for yes, twice for no? Yeah, okay. All right, so good. All right, so we understand that. So we have 0 to infinity getting plugged into the h of x function. Right? But h of x had a restriction. What was the restriction? -3. Okay? The problem is, which actually it's not a problem at all, is -3 in that range? No. So if I plug in -infinity to infinity, if I plug in any real number, am I ever going to have a problem? No, because the output will always be a number I can use, 0 to infinity. So the domain of this guy is going to be -infinity to infinity. Okay? I'm never going to get a value that causes me issues. I'm never going to get to that restriction, because the restriction is that we can't have 0 in the denominator. Well, that's never going to happen in this case. It's impossible to make this value equal -3. It can't happen. I don't care what you plug in for x dealing in the real number system.